In the present lecture, we are going to discussing about the gate previous problem on a simplex method. Let's see the problem. At the current basic feasible solution, that is V0, the simplex method yields the following form of a linear programming problem in standard form. Minimize z equal to minus x1 minus 2x2 subject to x3 equal to 2 plus 2x1 minus x2, x4 equal to 7 plus x1 minus 2x2, x5 equal to 3 minus x1. x1, x2, x3, x4 and x5 greater than or equal to the 0. Here the objective function is written as a function of the non-basic variables. If the simplex method moves to the adjacent basic feasible solution, that is V1, that best improves the objective function. Which of the following represents the objective function at assuming that the objective function is written in the same manner as above? Option A, z equal to minus 4 minus 5x1 plus 2x3. Option B, minus 3 plus x5 minus 2x2. Option C, z equal to minus 4 minus 5x1 plus 2x4. Option D, z equal to minus 6 minus 5x1 plus 2x3. This problem we can be solved by shortcut method or conventional simplex method. In this lecture, we will solve this problem by conventional simplex method. Let's see the solution. Here objective function is minimization model. Then you have to convert this minimization model into the maximization model by multiplying with the minus 1. Then objective function will become the maximize z equal to x1 plus 2x2. Here x1 and x2 are the basic variables. Next observe the constraints which is consisting of the x3, x4 and x5. So these x3, x4 and x5 are the slack variables. So once again we have to rewrite this constraint as a minus 2x1 plus x2 plus x3 equal to 2, minus x1 plus 2x2 plus x4 equal to the 7, x1 plus x5 equal to the 3. So here x1 and x2 are the basic variables, x3, x4 and x5 are the slack variables. So then once again we have to rewrite our objective function in the terms of the basic variables as well as in the terms of the slack variables. Then objective function will become the maximize z equal to x1 plus 2x2 plus 0x3 plus 0x4 plus 0x5. So next we have to find the initial basic feasible solution. For this we have to assuming the basic variables x1 and x2 are the 0. Then we have to substitute these x1 and x2 values in the constraint. Then we will get the x3 equal to 2, x4 equal to 7 and x5 equal to the 3. So next we have to construct the initial simplex table. So this is the initial simplex table. Next we have to determine the zj minus cj values to check the basic feasible solution for the optimality. So zj minus cj for the x1 basic variable, it is the 0 into 2 plus 0 into minus 1 plus 0 into 1 minus 1. So here it is the minus 1. Similarly for the x2 variable it is the minus 2, and for the x3 0 and x4 it is the 0 and x5 it is the 0. So here zj minus cj values are the minus 1, minus 2, 0, 0 and 0. So among these values we have to select the most negative zj minus cj values. So most negative zj minus cj value is the minus 2 for the x2 column. So here x2 column is the key column and calling as the incoming vector. So x2 variable enters into the basis. Next we have to calculate the minimum ratio of xp divided by ck. First we have to determine for the first row, for the x3 row. Here xb value is the 2 and ck value is the 1. Then 2 by 1, its value is the 2. Next for the x4 row, second row, that is the xb value is the 7 and ck value is the 2. 7 by 2, it is the 3.5. And next one is the 3 divided by 1, it is the 3. So among these values, minimum value is the 2. So minimum ratio is the 2 and indicated by arrow. Then x3 is calling as the outgoing vector or the key column. So basic variable x3 leaves the basis. Next we have to identify the common element in the key row as well as the key column. So here common element is the 1. This one we are calling as the key element. Next we have to once again construct the new simplex table by entering the incoming. So here x2 is enter into the basis and x3 is outgoing, it is leaves from the basis. So have to modify the simplex table. So in the CB here you have to enter the cost value for the x2, that is the 2, and in the basis you have to enter the x2 variable. So then once again you have to do the following row operation to get the 1, 0, 0 in the key column. So first we have to do the first row operation is the R1 new equal to R1 old, because here we have to get the value is 1. So already 1 is there. So then no need to modify the R1 old row. So R1 new equal to the R1 old. So next we have to do the row operation is the for R2. Here element is 2 is there. We have to get the 0. How we will get the 0? 2 minus 2, which mean R2 volt minus, so 2 into 1. So which is, I have to say that one, the R2 volt minus 2 into R1 new. So that is our second row operation. R2 new equal to R2 volt minus 2 R1 new. So first I have to write down the R2 volt elements as well as the R1 new elements. Then 2 into R1 new will become the 4 minus 4, 2, 2, 0, 0. Then I have to do the operation is R2 volt minus 2 R1 new, that is the 7 minus 4 and minus 1, minus half minus 4, 2 minus 2, 0 minus 2, 1 minus 0 and 0 minus 0. So first one here 7 minus 4, it is the 3, minus 1 minus half 4, it is the 3, and 2 minus 2, 0, 0 minus 2, minus 2, 1 minus 0, 1, 0 minus 0, 0. So next row operation is the R3 new equal to R3 volt, because here we have to get the 0 value, but already it is there 0. So no need of the any row operations. Same row values of the old table have to write down the same values in the new simplex table also, that is 3, 1, 0, 0, 0, 1. Next once again I have to determine the Zj minus Cj values. So Zj minus Cj value for the x1 column, it is the 2 into minus 2 and plus 0 into 3 plus 0 into 1. So minus 4 and minus 1, it is the minus 5. Similarly for the x2 column, it is the 2 into 1 plus 0 into 0 plus 0 into 0 minus 2, it is the 0. Similarly for the x3 column, it is the 2, and for the x4 it is the 0, and for x5 column also it is the 0. Here negative value is the minus 5 for the x1 column. So x1 column we are calling as the key column and it is calling as incoming vector. And x1 variable, it is enters into the basis. So next we have to determine the minimum ratio. So minimum ratio for the first row, that is the x2 row, we are not doing. So xb by ck value, because ck value is having the minus 2 negative value. So next one is the for the second row. So xb value is the 3 and ck value is also 3. So 3 by 3 it is the 1. Next one is the 3 by 1, it is the 3. So minimum value is the 1 for the x2 row, sorry x4 row, second row. So that row we are calling as the key row and it is indicating by the arrow and x4 is we are calling as the outgoing vector, and its x4 is leaves the basis. So next we have to identify the key element. It is the common in the key row as well as the key column. Here 3 is the common element and we are calling as the key element. Next once again we have to construct the new table. So here we have to modifying the, in the place of the x4 we have to enter the x1. Its cost coefficient is the 1. So next we have to do the following row operation to get the, here it is the 0 and here it is the 1 and here it is you have to get the 0. How we will get here 1 mean divided by 3. So R2 new equal to R2 old divided by 3. So R2 new elements are the 1, 1, 0, minus 2 by 3, minus 1 by 3 and 0. Next row operation is the R1 new equal to R1 old plus 2 R2 new. So these are the R1 old elements, this is the R2 new elements and this is the 2 R2 new elements. Now we have to do the operation is R1 old plus 2 R2 new, that is 2 plus 2 4, minus 2 plus 2 0, 1 plus 0 1, 1 minus 4 by 3 it is the minus 1 by 3, 0 plus 2 by 3 it is the 2 by 3, 0 plus 0 it is the 0. Next row operation is R3 new equal to R3 old minus R2 new, that is 3 minus 1 which is equal to the 2 and 1 minus 1 0, 0 minus 0 0, 0 minus of minus 2 by 3 it is the 2 by 3 and 0 minus 1 by 3 it is the minus 1 by 3, 1 minus 0 it is the 1. So next we have to calculate the Zj minus Cj values for the x1 column. So Zj minus Cj values are the 2 into 0 plus 1 into 1 plus 0 into 0 minus of 1 it is the 0. Similarly for the x2 column also 0 and for the x3 column so it is the 2 into minus 1 by 3 and minus 2 by 3 0 minus 0 its value is minus 2 by 3 and minus 2 by 3 it is the minus 4 by 3 and next one for the x4 column 2 into 2 by 3 it is the 4 by 3 plus 1 by 3 it is the 5 by 3 so it is here 5 by 3 and for the x5 column it is the 0. So here most negative value here only 1 Zj minus Cj is the negative value and its value is the minus 4 by 3 for the x3 column. So x3 column we are calling as the key column and it is calling as the incoming vector. So x3 variable enters into the basis. So next we have to determine the minimum ratio of xp divided by ck values. So for the first row we are not calculating the xb by ck because it is the ck value is minus 1 by 3 and next one also minus 2 by 3 and next one is the 2 divided by 2 by 3 its value is the 3. So here we are having the only one ratio, so minimum ratio is the 3 for the third row for the x5 row. So this row we are calling as the key row and x5 variable is outgoing vector and it is leaving from the basis. So next we have to identify the common element in the key row as well as the key column. Here 2 by 3 is the common element and that is we are calling as the key element. So next once again I have to construct the new simplex table. Next once again I have to construct the new simplex table by replacing the x5 with the x3 and its cost coefficient value is the 0. So next we have to do the following row operation to get the 0 and 0 and 1 here. So first row operation is R3 new equal to R3 old into 3 by 2. Then R3 new elements are the 3, 0, 0, 1, minus 1 by 2 and 3 by 2. So next row operation is the R2 new equal to R2 old plus 2 by 3 into R3 new. So this is the R2 old elements and this is the R3 new elements and this is the 2 by 3 into R3 new elements. Then I have to do the row operation is R2 old plus 2 by 3 into R3 new, that is 1 plus 2 it is the 3 1 plus 0, 1, 0 plus 0, 0, minus 2 by 3 plus 2 by 3, 0, 1 by 3 minus 1 by 3, it is the 0, and 0 plus 0, 0. So next row operation is the R1 new equal to R1 old plus 1 by 3 into R3 new. So this is the R1 old elements, and this is the R3 new elements, and this is the 1 by 3 into R3 new elements. Now we have to do the row operation is R1 old plus 1 by 3 into R3 new, that is 4 plus 1, 5, 0 plus 0, 0, 1 plus 0, 1, minus 1 by 3 plus 1 by 3, it is the 0, 2 by 3 plus minus 1 by 6, it is the 1 by 2, and 0 plus 0, it is the 0. So next once again I have to calculate the Zj minus Cj values. First I have to calculate for the x1 column, it is the 2 into 0, 0 plus 1 into 1, 1, and minus 1, it is the 0. Similarly for the x2 column it is the 0, and for the x3 column also it is the 0, and for x4 column 2 into 1 by 2, 1, and 0, 0, and 1 here will be get, and for the xy column, so here also we will get the 0. So here observe the all the Zj minus Cj values are the positive, which means greater than or equal to the 0, then we will get the optimal solution is obtained. Then optimal basic feasible solution is x1 value is the 3, x2 value is the 5, and x3 also become the basic variable and its value is the 3. Then substitute in the objective function, that is z equal to minimize z equal to minus x1 minus 2x2. Substitute and x1 x2 values, we will get the z equal to minus 13. Let's check the given options. Option A is z equal to minus 4 minus 5x1 plus 2x3, its value is the minus 13. And for the option B, x5 is not a basic variable, so option B is not correct. For the option C also x4 is not a basic variable, so option C also not correct. And I have to check for the option D, z equal to minus 6 minus 5x1 plus 2x3, its value is the minus 15. So here objective function value is z value is the minus 13, so option A is the correct. So this is the solution by the conventional method. So next coming lecture we will be discussed by the shortcut method, and thank you.